Assalamualaikum, my name is Muhammad Taufik bin Kamaruddin from Group 4, and I'll be presenting about heavy duty slip fit base. Moving on to introduction. Our project background is fabricating product by using an operational C application from mass produce. Construct a product involved in our daily lives. C application have to consist to function, to looping, and to varieties of decision. The fabricating unit is proposed to be engaged in manufacturer. Our problem statement is large variety of labor done by this factory increase the value for this factory to cover a lot of employee to possess far better work efficiency. Secondly, work efficiency will be enhanced in having a better arrangement in work, increasing the number of workers and increasing the number of machine use. Moving on to project objective. Our objective is mainly to obtain more efficient schedule in order to reconstruct the time and settle more business. Secondly, to apply that and execute the solution in company additionally around the department by constructing program in C language. Moving on to second chapter, which is literature review or methodology. So basically we have three types of machine that involved in our operation, which is milling machine, lathe machine, and drilling machines. Both those machines are all combined together to perform in our manufacture product. Secondly, we have raw materials. So as we can see here, while a mild steel round bar is needed in our production, we need 10 millimeters, 20 millimeters, and 30 millimeters, which is various mild steel round bar. There are also a few other parts that we still needed, which is consists of various type of quantity and price itself. Next, we have two type of plate which is used in our project of heavy slip fit duty base. So the first plate is 2000 times 1000 and 3 mm. The second plate is 2000 times 1000 times 4 mm, which is the weight of each of the steel plate is also different by almost 2 kilos. So the unit price also is slightly different, which is cost us around 2 ringgit 60 something, but that's all we need for our project. We're moving on to the next part, which is transportation and logistics. So we are using a carton box to transport our product from the manufacturer to our client. So we're using three types of box, which is various length of the box and thickness as well. The cost of the box also will be different, depends on its size. Next is transportation. We have two type of truck, consists of max loads differently. So the first truck will be max at 14,000 kilogram, which is the second truck with max load of 20,000 kilogram, which is each of them 40,000 kilogram of truck will cost us around 480 ringgit, and 2,000 kilogram, which is equal to 2 ton, is cost us around 600 ringgit. Lastly, the product design. So as we can see in the slides, we've been inserting the 2D sketch of our product. The justification is cases of the dimensional changes are numbers of gaps, length, width, thickness of the item. The display 2D item plan concurring to the stiff parameters of the plan, and test 2D drawing is appeared within the picture.
Assalamualaikum and hi. My name is Muhammad Shahrul Izzat bin Shamsuzari. My metric number is CD190265. Today I will present about the methodology of the project. As an Information Technology Agency, our organization has built the C program to support mechanical design, production planning, manufacturing, packaging, and logistics. So here is the job where the C program have to consist of two function, two looping function, and two decision operation types. Then we can see the project design. Our group choose the number 8 of project design. Next, we go to the flow chart. As you can see to the slide, it's not clearly on the slide, the flow chart. So I will show you on the words. So I show you the flow chart in the word. We start with start and then the input, width, length, diameter, and height. Then we have the decision of length if it's over 21 and not over 21. The output will become the below the length one. If yes, then I equal to 0, I equal to I plus 1, and then we go to the width if they're over than 21 or not over than 21. If yes, the output is below that, and no, the output is on the right one. And then we have the decision I bigger than width. If yes, they will output on the below one. If no, they will repeat with I equal to 0. Then we go to the next, the output. Output will become output 1 plus output 2 divide I plus I output 1. Then below that we have the decision about the diameter. Diameter small than 6. If the diameter small than 6, the output is below. If no, the output on the left side. Then we got into I equal to 0 again, and I equal to I plus 1. Then below that we have the decision of height. Height small than 21. If yes, the output is below. If no, the output is on the left side. Then we go to the decision of height, the last one. I is bigger than height. If yes, the output is below. If no, they will repeat to the I equal to 0. Then the output will become output 3 plus output 4 divide I plus output 1, and then the end. So I will try running this C program, and we insert the value. For the length is 10, for the height 20, for the width base is 5, for the diameter is 2. So that's the result I show you. That's all from me. Thank you.
Hello and Assalamualaikum. My name is Aiman Daniel bin Muhammad. My matric number is CD190022. Today I'm going to explain about production planning for computer programming group project. First, I will explain about flowchart. Second is coding input, and lastly for coding output. For flowchart, we begin with start, then we state 5 lists of material, then input length, width, diameter, and height. Then we can either choose material 1, 2, or 3. If we choose material 1, the weight is X equal to 0.62 kilogram per meter, and the price is Y equal to 2 ringgit and 78 cents per kilogram. If we choose material 2, X equal to 2.747 kilogram per meter, and price Y equal to 2 ringgit and 33 cents per kilogram. If we choose material 3, X equal to 5.55 kilogram per meter, and the price is Y equal to 2 ringgit and 18 cents per kilogram. Input are to remove. we remove the part that is unused. Then we either can choose material 4 or 5. If we choose material 4, A equal to 23.55 kilogram per meter cube per meter square, and B equal to 2 ringgit and 60 cent per kilogram. If we choose material 5, A equal to 31.40 kilogram per meter square, and price B equal to 2 ringgit and 60 cent per kilogram. If we not state 4 or 5, other than 4 or 5, the output will display error. Then for the price 1 is for material 1, 2 or 3, and price 2 is for material 4 or 5. Input quantity of product. We will input the quantity of the product. Next is total price equal to total price 1 and price 2. Then output material selected, quantity, total price. Then N. So that is the output. List of available material. Material 1, 2 and 3. Next is 4 and 5 for my steel plate and my steel round bar. Next, we enter the length of the base in mm. We choose to select 10. Enter the width of the base in mm, 15. And 10, we enter to the diameter of the solid bar in mm. Next is 15 millimeter. We enter for the length of the solid bar or height. Select material used for base 4 or 5. We use material 4. That is 2.6 kilogram. 2.6 per kilogram. Then enter the area of the base removed in mm square. That is 2. Select the material used for the solid bar. We choose to select material 2. The price is 2 ringgit and 33 cent per kilogram. So the total of the raw material needed for the product is 9 ringgit and 27 cent. The unused material for the product is 3.56 kilogram. The quantity is 1. Process, drilling and milling. Material type 2000 by 1000 by 3 millimeter mild steel plate. That is equal to 23.55 kilogram over m square. Quantity 1, process turning material type 20 mm diameter mild steel round bar. That is equal 2.47 kilogram per meter. Quantity 1, the total product for the total price of the one product are 9 ringgit and 27 cent. The unused material for one product are 3.56 kilogram. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Ahmad. I will explain about the fabrication process in our project. So, in the fabrication process, we have 4 process in the programming. So, we have the drilling, side milling, pocket milling, and turning. So, we have the 4 process we have to program this machine. So we start the process. Number 1 is drilling. So the output is out into the diameter of hole in. We put 5 millimeter. So the second one, into the feed rate is use 10. Time used for drilling a hole is 240 seconds. So we get the energy used for drilling in hole is 0.985 watt. So the number of hole we want to if we took T. So we got the time before dealing is 722 seconds, equal to 12 minutes. The energy for dealing is 2.957024. So how to get that? So In the right side, we saw the process for dealing. We saw the diameter of hole 5 mm, freight rate 10 mm per reverse speed, speed 1 per 10, 0.1, cutting speed 3.142, time 5 times 0.1 per 1000 equal to 0.001571 meter per minute. So we use the rule 5 times 0.00157 per equal to 0.98. So what time for dealing 3 hole? 2014 times C equal to 730 seconds equal to 2 minutes. Energy for dealing 3 hole 0.98567 times 3, we got the 2.95. So this is the process of dealing process. So process number 2 is side milling. In the output of the program, we got the intercutting with millimeter. So given we took 15 enter the revolution per minute. We type 16 rpm. Enter the rate used, so we took 10 minutes. So we got the time used of slot machine is 1.5 second, 4.5 minute. The energy used for slot machine is 90.5. So how do you get that? So in the right side, 2 per feet per second, 10 divide by 4 times 0.1, we got to 0.25 millimeter per foot. So the 2 per feet is between the value of 0.2 and 0.3. So the specific cutting force will be 1915 megapascal. So energy used for milling 4 times 15 times 10 times 1915 divided by 600,000. So we got 90.5 watt. So this is the process 2 side milling. The process. So the next one is process number 3, turn pocket milling machine. So the output we get into the cutting width. So we put 10 millimeter. So evolution per minute, we got 600 rpm, 16 rpm. The feed rate you use 10 rpm. So we got the time used for pocket milling is 1 second or 1 minute. The energy used for pocket milling is 30 watts. So how to get that? So the right side we get time for slot machine is time 10 times 16 divided by 16 times 10 to equal to 1 minute. To perfect 10 the equation is 10 times 4 divided by 0.1 equal to 0.25 mn per 2. So to prove it is between the value of the 0.2, 0.3. So it is similar the slot milling. So we got the 1915 megapascal. So we use the energy used for slot milling for 4 times 10 times 10 times 1915 divided by 60,000, you got the 30 watt. So that's all. After that, the input post need to for turning process are length of the solid wood, original diameter of the root, desired diameter of the root, and the feed rate. So the calculation show this. So the process, the last process is turning process. So we got the length of the root in mm 10 into the diameter of the root in mm 5 into the diameter for root in mm 2.5 into the feed rate is 7 mm per ribbon. The time returning, so we got the time returning is 12.24 second or minute. Energy used for turning is 0.00202 watt. So how do you get that? So we got the cutting speed in 0.002244. To per feet we got the 0. 2 to 5 and 2. So the two fit in between value of 0.2 and 0.3. So the specific cutting force will be 3,100 megapascal. So energy for turning 5 minus 2.5 times 7 times 0.002244 times 3,100 divided by 60,000, we got the 0.002029 watt. So after calculate time energy used for each process, according we calculate the total time energy or the process for product each time use all the process product. So we got 12 time 1.5 time 1 time 12.1225, we got 26.74 minutes, so equal to 0.45 hour. So energy used in the all process for all product, so we got total 35.459,056 watt. So the total energy used of process remain the same, so the total product is unit is 1. So that's for me. So we continue about the packaging and logistics.
Assalamualaikum warahmatullahi wabarakatuh. Today my name is Muhammad Nawakimi bin Kahlil. Today I would like to present to you about the packaging and logistic process. Basically, I would like to present about the flow chart for the process, coding and the result. The flowchart for this process, I combine the packaging and logistic process, which is for the packaging is input length, width and height of the product quantity, box 1, box 2, box 3, and for the logistic is lorry 1 and lorry 2. The user will choose whether they want to choose box 1, box 2 or box 3 for the packaging, and the price is RM10 for the box 1, RM12 for the box 2 and RM20 for the box 3. If the user choose box 1, then the program will show the logistic, which is lorry 1 and lorry 2. Then when the user choose lorry 1, the price for the lorry 1 is 250 and the price for lorry 2 is 450. And then the program will calculate the total, which is the packaging price plus the logistic price and equal to the total price. Then the program will end. Okay, basically this is the result for this coding. So we try to insert the product spec, which is 45 for the width, 50 for the length and 35 for the height. Then enter the quantity, which is I choose about 20, and the size box used I choose box 2, and the logistic, so I would like to choose the truck 2. Okay, this is the result for the coding. The total price for logistic is 1080, and the price for the logistic plus the box price is 1095. That's all for me. Thank you.
The conclusion of our project is we successfully achieved our objective in this project, to run a business in manufacturing company. Secondly, each of the member of the group in our group managed to develop C programming for each part in mechanical design, production, planning, fabrication, packaging and logistics. Moreover, our recommendation to the company is more workers should be added in production team in order to produce more idea and increase production. Time management also needed in order to avoid confusion in factory and meet customer demand or requirement. Last but not least, discussion among the staff in manufacturing companies should be more clear and avoid the quarrels and create proper business environment. Thank you.